wonderful to be here with you all this evening. I want to thank Pete for giving me this opportunity to share something a little different with you all tonight, how AI could be used to conserve species and protect the Earth's biodiversity. So, I'm Ashlee, I'm a program manager at Revive and Restore. As Pete has explained, this is the non-profit conservation organisation that was actually founded right here in San Francisco by Stuart Brand and Ryan Phelan. And our mission is to bring biotechnologies to the conservation of endangered and extinct species. As a stem cell scientist, I'm particularly focused on how we can use induced pluripotent stem cells, or IPSCs, to prevent further extinctions. And I've become lately very interested in how AI could be used to fast-track this important technology. So I'm sure we've all heard it said at one point or another that AI will give us a way to harness all of human intelligence. Well, I'm really excited to share that we're actually entering an almost parallel phase in our ability to harness all of developmental biology. Because thanks to stem cells, we now have the power to grow a whole animal from the starting point of a skin sample. So what does this have to do with AI and how is it important for biodiversity? Well, some of the greatest threats that wild populations face in this changing world are habitat loss and population fragmentation. And as endangered populations shrink, so too does their gene pool, and they become susceptible to inbreeding. And without genetic variation, they can't adapt to environmental challenges, and they're likely to become extinct. Well, what if we had the power to take any endangered species and make more whenever we wanted, producing healthy new individuals full of genetic variation? What if we could incorporate genetic engineering to further induce that variation for resistance to disease or climate change, and to restore the Earth's biodiversity, and with it, all of the economic benefits that come with a healthy planet? Well, I'm here to tell you that we can. This is possible, and we already have all these tools at our disposal through advances in stem cell technology, genomics, and bioengineering. So for some context, for those of you who aren't super familiar, back in 2006, when Yamanaka won the Nobel Prize for showing that you could take any old cell from the body, reprogram it back to a pluripotent stem cell. So those are the stem cells that are functionally the same as what we see in the earliest embryos, and that means they have the power to become anything, any part of the animal. So back when this discovery was made, this rocked the world of medicine, I'm sure many of you remember, and the game changed for the future of this planet. Because we now know that it is possible to produce offspring from the starting point of a skin sample, from a speck of biological material obtained ethically, non-invasively, and remarkably, we're already starting to see scientists converting these induced stem cells into functional sperm and eggs. And we've shown that there are a number of ways they can also be used to make an embryo. And we've shown that we can make these induced pluripotent stem cells for a number of endangered species, but no one has yet scaled this up as a viable conservation solution. So what's the hold-up? And I speak from experience here. Well, it takes years and years every time you want to get this working for a new species. There are so many factors to test. This was certainly my experience back in Melbourne when I was generating these cells for a marsupial model, the fat-tailed dunnart. And unfortunately, I think we're looking at decades before scientists can develop these foundational methods for most endangered species. And we're running out of time. At the moment, we're losing species with unprecedented speed, and current conservation methods, like habitat restoration, simply can't keep pace with the rate of loss that we're seeing. But to derive stem cells from all these different species and make offspring, that will require us to really unpack the regulation of pluripotency across all these distinct lineages, and here is where I see AI emerging as a way to unravel all that biological complexity and really speed things up. So at Revive and Restore, we're starting to work toward developing and training a neural network on all the available data that we have produced for pluripotent stem cells across different species, and using this to predict reprogramming methods based on the genome and evolutionary phylogeny of that species. Now, if this works, this would enable the rapid derivation of stem cells for all the species that most need it. and could next be used in the same way to generate other cell types. And of course, I'm thinking here of sperm and eggs. So this would really give us the power to bring any species back from the brink of extinction. But AI won't just give us ways to make better stem cells. Thinking more broadly within conservation and conservation genomics, it could tell us which individuals to translocate to improve the genetic health of a population. It could fill in the gaps when genetic information is missing. It could tell us which genetic variants are most likely to deliver the best adaptations to climate change. And a really important direction here would be coral, with reefs undergoing a fourth mass bleaching event as a result of warming waters. So I'd like to thank you for digesting a complex topic with me tonight and finish with a question for the room. What happens when you partner two transformative technologies, stem cell tech and artificial intelligence, to deliver a scalable system and method to harness the developmental potential of any species? Well, I'm here till tomorrow and I'm excited to talk with anyone who's interested in exploring this opportunity with me. Thank you.